Although rare, there are instances when lightning rods can be struck, and let's take a look at one of those instances. So, to recap, the negative cloud comes over the structure. There's a charge redistribution in this conductor here, and so electrons are pushed down out of the conductor into the Earth. The Earth itself is a conductor, and so the charge is pushed down into the Earth. The top of the Earth is becoming positively charged due to that charge redistribution. And because there's a tip right here, it's ionizing the air, and electrons are being sucked out of the air, and the positive resulting ions are being streamed back up into the cloud, thus capturing some of these electrons here and neutralizing the region above the structure, protecting a shield that protects the structure from being struck by lightning. And that is the primary mover and reason for the lightning rod. There is an instance, though, there are instances where the charge will be building up in the cloud. The time rate of change, how fast it's building up, the charge will be building up in the cloud faster than the lightning rod can ionize the air. And when that occurs, you could have a strike, because you'll still have negative charge here because it's building up. The negative charge is coming in faster than this guy can send ions up to neutralize those electrons that are coming in. And so we'll still have a net negative charge underneath the cloud, and so there will be a probability of strike. Under this scenario, the lightning rod will have the highest probability of being struck, because by design it's located at the tallest point on the structure. So because it's closest to the cloud and it's positively charged, even if the building's made of concrete, is a conductor also, believe it or not. And so if the structure is made of concrete, there'll be charge redistribution and polarization in the concrete also. The charge will be pushed down to the bottom of the structure, and the structure will become positive on the roof. Okay? But this point here, because it's the tallest place, it will have the highest probability of strike. Okay, so this is a scenario where a lightning rod could be struck. Now, what if you don't ground it? How about that? What if it accidentally gets hit by a weed eater or something and it's not grounded anymore? What then? Well, this is what would happen. It's not good, okay? Because this thing will become positively charged. The electrons are still being pushed down, but they have nowhere to go. And so they start piling up and creating a net electric field that is in opposition to this electric field. And so essentially, they are taking away from the positive the effect of this positive charge up here, because these electrons are piling up in the conductor down here. Okay, so you want it grounded so the electrons can dump to Earth, and this guy can become as positive as possible and ionize as many atoms as possible and send them up into the cloud. These are called the positive streamers, so we talked about that previously. And these positive streamers capture electrons and neutralize this region of the cloud. So you want to make sure that this is grounded. And where is the safest place? I think we discussed this. I can't remember. I'll say it again. The safest place to be is low-lying flat areas away from tall structures, because you never want to assume that someone grounded a lightning rod. Never assume that it was grounded properly. And you want to be away from structures in the lowest place you can be, as this is the safest location. Okay, that's it for lightning rods. I'm going to step out of the side and give you a clear screenshot. Moving on.